Hello and welcome back to another DevOps For Everyone session. It's been a while. It was great to meet and chat with Mohan, the VP of Products at Rafay, a couple of weeks ago. This is actually the first in a two-part series that I'll be hosting with Mohan. And in today's session, we hear about some Kubernetes stories from the trench. Typical issues that we'll cover include access control, quality of service, pod auto-scaling, Kubernetes strengths, Kubernetes Upgrades, Audit Trail, the list goes on. Mohan's a really knowledgeable guy on this subject. Something that really touched on that caught my attention was not giving God mode access to all users when it comes to Kubernetes. Give your people single sign-on experience. It's really, really insightful. I hope you enjoy it. This is episode 1, as I say, so I'll see you on episode 2. Thank you to those that have joined. Really good to see some people returning. I see some familiar names and also some new names as well. The first time that Mohan has spoken at one of these events, so pleasure having you on, Mohan. I just wanted to start by welcoming everybody, obviously, to another session of DevOps For Everyone. It's been the best part of, I think, 2 months now since we've done an event, and I've been really looking forward to this one because Rafay, who Mohan works for, is a company that I've been interacting with now for the best part of a year, I would say. I think this is maybe now the third time attending one of the meetups, so turning into a really great partner for DevOps For Everyone. So I'm happy to have you guys here. Mohan, if it's all right, I'll just give a really short introduction. No doubt you'll do it much more justice, but I always like to introduce the guests on the episodes and sort of do my best. So Mohan is Rafay's Vice President of Products and has been with the business since, I believe, January 2019. Prior to this, Mohan worked at Okta, Neustar, Intel Security, and Cisco. So no doubt you've heard of some of those big organizations. Today at Rafay, he focuses his time on application lifestyle management for containerized applications. And today he'll be sharing some stories of Rafay, and actually sharing some stories of Rafay in the trench, talking about Kubernetes problems and how they've solved them. So really eager to hear it from Mohan. For those who don't know Rafay, they offer a turnkey solution that automates Kubernetes cluster management, application deployment, and operations at scale. So simply put, Rafay's platform eliminates the need to build an in-house platform. So that's my introduction. I hope I did you justice there, Mohan.
Yeah, Joe, all good, all good. Yeah, I mean, I see today's session as a lot for the folks who are here. I mean, thank you for making time. So what I thought was, and Joe, can I start sharing? And
give me 1 second.
Yeah.
Yes, now you can.
Yeah, perfect. Let me share my screen, and let me flip to my slides. I have a few slides. And what I'll do today is kind of walk through the reason. So when Joe and I talked about this a few weeks ago, I was kind of telling him that, hey, there's some very interesting war stories that we learned, I guess, the hard way, because we work in the trenches with our customers, right? So, we have had the opportunity to solve hard problems with our customers together with them. And many a times we have a fall and stumble with them, and then we get over the issues. And I thought we'll share some of these because they're interesting. We don't want anyone starting out with Kubernetes to make the same mistakes again, right? Because some of them are really bad. So this is our way of giving back what we can in the form of this meetup where we can share this informally. So by no means consider this as a one-way thing. This is for you guys. So ask questions, interrupt me. I know the virtual format is kind of hard. It's no replacement for our face-to-face, but we'll try and do what we can. So feel free to stop me anytime. Okay. It's a little bit about me, and if you want to, after this, if you want to get hold of me, you see my Twitter handle, my LinkedIn profile, and my email. If any questions about Kubernetes or Rafay that comes up after the session, by all means, reach out. Happy to connect with people, happy to share, and maybe if you have a particular challenge or something, we're happy to explore this together with you. So with that, let me move on to the topics we're going to talk about today. So Joe and I are hoping to do this in a multi-part set of sessions. There's a lot of interesting issues that people have to overcome with Kubernetes. It's after all a brand new way of building and operating your applications. Now today, we'll be covering perhaps the most interesting topic. This is a topic that we see people make really, really bad mistakes with, and we want to make sure that we take that on first. It's essentially access control. And the particular problem here, as I laid out, is as operators of Kubernetes or DevOps teams, etc., the typical practice is, yeah, I provision a cluster, great. Now the developer says, so how am I going to access it? How am I going to troubleshoot it? You have a step one issue with your application. You let people in, let them do their job. The developer fixes stuff, and then the auditor comes back and says, prove to me that you didn't do anything bad. Well, now you're stuck. So all these turn out to be really nasty problems at steady state. So we thought we'll take care of access control today, and I'll take about 3-4 examples, and I'll not just be slides, I'll actually show you demos, because I also been in many of these meetups before, and PowerPoint, and we see enough of that all through the day. So I'll kind of show a couple of slides, lay out the scenario, and very quickly flip to a demo showing what it could look like if you did it properly. And in future sessions, depending on, we'll kind of bring this up towards the end, let you guys vote on the topics, because some people want to hear about quality of service, like if I don't set up QoS for my resources, what happens? Some people want to hear about how the hell does autoscaling work, like HPA or cluster autoscaler. That's another topic that we'll take on eventually. One of the hot topics that I see with pretty much 100% of our larger customers is struggling with secrets management. Then we'll talk about Kubernetes upgrades if you guys are interested. And then things like, how do you do audits to run a business that is mission critical? So today's topic is access control. The rest of them, we'll pick them up as we go on with Joe. And if you have any particular topics you think, man, this is really, really interesting, can you do that first or the other, please let us know. Okay. So let's talk about the first issue. This is something that we used to see about 2 years ago very frequently, and we thought, oh my God, this is not good. And here's why. The situation we would see is some operations person or a DevOps person who would have spun up an EKS cluster or some other do-it-yourself Kubernetes cluster, and the API server would be exposed and visible on the internet. I mean, this is an absolute no-no. And we'd go ask them, hey, why have we done that? And a lot of them said that, hey, it's a pre-production environment. Our developers and operations personnel, they hate using a bastion, hate using VPNs because the performance and user experience is really bad. I mean, I don't know how many of you live with a bastion and a VPN for other things, but I'm sure you might have gotten used to that pain, but it's not exactly pleasant if you're an application developer. The recommended and desired state should be, cloak your clusters, control plane. And I'll talk about a hack that happened 2 years ago. I'm sure all of you know about what Tesla went through. Tesla made the mistake. Again, this is not just a small company that makes these mistakes. Big companies also land up making these mistakes. It's an innocent error. So best practice is the way out. The Tesla had a situation where their API server for the Kubernetes clusters was inadvertently exposed and accessible on the internet, and they landed up getting compromised as a result. Right? So never do that. There is a way by which you can still have private cloaked clusters. And when I say cloaked clusters, which means the endpoint is not accessible over the internet, which means no one can perform, no one can take it down, no one can manipulate it, no one can attack it. They can do all this without compromising developer experience or dev velocity. We'll kind of show how easy it is to do this in a demo very soon. That's number one. Issue two, that we see this very frequently with many people, especially that are early in the process. And the situation is, and usually this starts off with that Bastion thing, right? They'll end up saying, look, we just have one kube config. We put it in our Bastion. And as long as people get into the Bastion, if they authenticate and somehow get into the Bastion, they seem to have cluster admin kind of privileges, and all developers are effectively operating in God mode. I mean, that's also a bad practice, because if you have a single kubeconfig file, that itself is a problem, because now you don't know which user did what, because all you know is someone who had access to the kubeconfig and the Bastion was able to do this on the Kubernetes cluster. That's the first problem. Second problem is, well, that's a highly privileged kubeconfig. Why do you want to give a God mode to a developer who can do all kind of damage? So we asked them why, and it was obvious, but I think they repeated what we knew. Managing Kubernetes RBAC on a per Kubernetes cluster basis and a per user basis is a nightmare, right? Like, think about it. Developers keep changing roles. They move from team 1 to team 2. Your clusters, you may have ephemeral clusters, and doing this dynamically is a royal pain. And what people want there is a way to centralize this access policy. Say that, hey, look, if I have 10 clusters, I don't want to be doing this cluster by cluster. It's a waste of time. And well, the user's identity is anyway sitting in a corporate directory. Whether you use Active Directory or ADFS or Azure AD or Okta or one of these many different things that exist, the user's identity, company identity sits there. Why not use that to drive Kubernetes RBAC? Is there a way to achieve that? And by the way, can you do this from a developers and operational personnel without having to make life cumbersome for them? But teaching them something new is hard, right? It's painful, it slows people down. So these are some of the things that we've heard again and again from people saying, hey, I want to help avoid that. That's issue number 2. It looks like there's some questions. Let me make sure that, okay. Joe, you might want to feel free to interrupt me if there are interesting questions that come along.
I think someone's screen froze, but it said it's back now.
Okay.
Cool.
Okay, perfect. The third thing that we hear again and again, especially for companies that are operating in regulated industries, or those who have to worry about SOC 2 compliance, which is pretty much any company these days, right? They'll end up saying, look, I want all my cluster admins, they need to use strong MFA, ideally something like a hardware token, before they can access remote clusters. Just sticking with passwords or weak authentication, it's a no-no, because they just won't pass any of these compliance requirements. They want to do this in a manner that's transparent and seamless for the admin, right? No complexity. And can they get this done without having to do some complex things? So that's number 3 that keeps coming up from a best practice. Number 4, which usually people don't feel the pain until they get audited, until a security team starts breathing down your neck, the lack of an audit trail. So someone comes and asks, hey, what does this developer do the last time they access? And everyone's looking at each other saying, I have no idea, right? I can't reconstruct. I have no forensic trail. This does not help anybody from a from an audit perspective or a compliance perspective, right? So the ideal state for that is, you need to find a way to aggregate and centralize the kubectl logs from every Kubernetes cluster, be able to say, I know exactly what commands this user, John Smith, performed from time 0 to time 2, and be able to reconstruct everything back. So these are some, we put 4 simple topics, issues associated with the whole access control space. I mean, just want to point out that just the little space of Kubernetes access control can be a royal pain for people. So yeah, when we started working on all these challenges with our customers, these are the things they highlighted. They said, hey, can you help us address these? So what I'll do now is we'll kind of switch on to a demo, and I'll kind of share what this could look like, an example of how each of these issues can be tackled one at a time. Okay. So let me move on to the demo. Before I do that, I just had to show you one small thing here. The scenario I'm going to demo. So in any organization, you have layers of people who need different privileges. So I'm going to take this particular example and show you this example company where things are structured a certain way. Okay. The example I'm going to show you is a company called OpenC2. And this architecture I'm showing you here, this is design, is something that we see again and again and again with companies, right? So it's a fairly portable best practice that you could just take and say, hey, this works for me too. So we'll kind of talk about multi-tenancy first. So any big business or an enterprise will typically have multiple environments, and they may need different people accessing the different environments. Here I have a project called Dev, a project called QA. There may be a certain number of clusters in the QA project, but not everybody in the company needs to be able to see the QA project. Only a few people need to see it. In this case, John Smith, who is maybe a project admin, maybe like a manager or something like that, he may need access to all the applications, right? He needs to see all the applications in that particular project, versus Chris Riley, whose job, hey, my job is just take care of the clusters. I don't need to see the applications. So a very common pattern with companies is I want separation of duties, right? Like somehow separate between an app developer and a cluster administrator, right? And we'll see how that can be seamlessly implemented via single sign-on experience. Now, remember, we also talked about infrastructure admins being privileged admins. So we'll in our demo, what we'll see is when Chris logs in, he'll be prompted for strong authentication. I'll show you how that can be done with the YubiKey. And then the lowest level here is an app developer. Now, in this case, Mark Lee, who is an app developer, in this project, he's been told, hey, your job is to just worry about your application called Redis in the namespace of Redis. But you can't even do any privileged operations in that Redis namespace. You should somehow be locked down. You can only do read-only operations, right? Now, this is although it looks standard, if you had to model this yourself with Kubernetes RBAC, you're probably going to get a headache, right? And believe me, I mean, we've tried it. It's not easy. And we said, hey, this is something that has to be tied back to corporate identity, as in some corporate directory like Okta or something else where these users will live. So let's see a demo of that, right? So let's start off with this guy called Matt Ray. So the first experience you're going to see is Matt Ray, who is an employee of the OpenC2 org. He's a top-level admin. And when he logs in, he will see all projects, all clusters. He is the administrator of the customer's Rafay tenant. Okay, let's see that. I'm going to share my screen. Bear with me 1 second. So I have built out profiles for these. So let me kind of go there. So the first person is Matt Ray. And just like all of us, when we log in the morning. By the way, is the resolution okay? Can you guys see the size, or should I make it bigger?
Yeah, that's it. That's better.
Yeah. Okay. So all employees in a company, maybe they log in with, Azure AD, or in this case is Okta. And, Rafay is one of the many different applications that they have. So when Matt Ray clicks on the Rafay chiclet, he goes into the Rafay console, and there are many projects. You can see many of the clusters. You can navigate all the various business units or environments that exist in this company. And what happened here is the company's directory, when it redirected Matt Ray to the Kubernetes management console, it said, hey, this guy, Matt Ray, belongs to this group called org admin, which automatically mapped to the top level administrative role in the Rafay console, and that let him in, and he can see everything. So he can not only see this cluster, but he can also see maybe the QA project and all projects. He can see everything. He's like the top level admin, right? So seamless access. Tomorrow there's a new employee who joins the company and he's an org admin. He simply gets added to the company's directory, and that person would have seamless access as well. So no monkeying around one by one, right? So now let's move on lower level, right? So Matt, where he could see everything, and he saw that particular tenant had many projects, many clusters. There were probably at least 20, 30 clusters there. Now we're going to see an example where things are going to get locked down by environment. So now let's start with John Smith, right? John Smith and Chris, they are top level admins in the QA project. So the company has kind of said, hey, we're going to need you guys to authenticate with MFA, right? So John Smith and Chris, they're going to use different kinds of MFA though, right? So let's start with John Smith. So John Smith is John's here, and same thing, same consistent experience. John logs into Okta in this case. Then no training needed because everyone has learned how to access this chiclet. So they click on the Rafay chiclet to access Kubernetes. They click that. And notice here, this is prompting the user for an MFA. In this case, I'm using an MFA app called Okta Verify, and I'm asking it to push the code to my phone. You can't see this, but I'll kind of prompt it here and show it the best I can. So here, it's asking me on my app, do you try to log in? So I'm going to say yes. And after it logs me in, notice here, this user, John Smith, can only see the QA project, and he's a project admin because he belongs to the group called Project Admin QA Project in the corporate directory. So tomorrow, if there's Jackie who gets added to that group, when Jackie logs in, well, she'll see the same thing, right? So access experience is seamless. Now, notice one thing. This guy, John Smith, he cannot see the clusters. He can only see the applications. Remember I said in this thing, the application developers and the cluster administrators, this company had decided, I want separation, right? So here, although, let me go back to that other console here. So John Smith logs in. He can see all the applications across all the namespaces on the clusters, but cannot directly mess around with cluster lifecycle management. Why? Because that job belongs to Chris in this case, right? The company has decided to have fine-grained controls in separation of duties. But this guy can go in and deploy applications, publish them, all of those things they can do by themselves. Okay, so that's an example of how easy it is for users. Now I'm going to show the most interesting part in a second. Just bear with me as I come back to that particular thing. So now we'll see Chris. Remember I said Chris can only do cluster administrator. He cannot do application lifecycle management because that job is not his responsibility. So they've gone down the least privileged route. So let's see Chris. But Chris the company says, gosh, Chris, you can kill clusters. If someone hacks into your account, we'll be in a very bad shape. So for Chris, what they expect him to do, I don't know if you guys can see this thing on the camera. It's a YubiKey token. Can you guys see this picture? This thing as I'm holding up?
Yeah.
So I'm going to plug that back in. So this is a hardware authenticator, right? So it's a very common requirement for highly privileged administrators where they say that, hey, you got to use a strongest form of authentication before you can access your Kubernetes clusters, right? So when Chris logs in and he clicks on the Rafay chiclet to access the console for accessing all these clusters, notice the thing prompts him, hey, enter your USB key. So you put that in, and in this case, I authenticated myself, so I'm in, and I'm going to see the clusters, and I can explore my clusters. I'll make this bigger so you can see it, right? Even though this cluster is running behind a firewall in a data center, it is actually running in a colo, right? In a data center, it's running behind a firewall, but I can kubectl to it as a user, right? I can do my favorite kubectl operation, even though this cluster is behind a firewall. I can access it, right? So I'll also show this just-in-time access in a second. Just give me 1 second. So since this user accessed this cluster for the first time, one of the big problems people land up running into is, let me just bring this up and show it. So notice this guy, Chris Riley at OpenSecret.io, he just logged in, right? Notice that this user's service account was just created on this cluster. So what's happening here is when the user needs to access the Kubernetes cluster, a service account, in this case, the Rafay controller is authenticating the user. It's checking, hey, does the user have privileges to do this, yes or no? And if yes, it automatically generates a write RBAC based on the current state of the user. If the user's role changes tomorrow, he will see something different. It's completely dynamic, right? So this service account is dynamically created, and then it'll be removed. So there are no permanent credentials. There are no dangling credentials, which is why you're able to kind of move the RBAC dynamically based on the user's role and other access policies, right? So this is a big deal for organizations. Without this, you're basically stuck in what I call as static access policies, which are just, you're opening the door at that point of time to getting hacked. So that's an example of how seamless it is to access and manage your Kubernetes clusters using dynamic RBAC. Now notice one more thing, this guy can see the clusters, but he cannot see the applications, not directly at least. He can't manage the lifecycle of the applications. So that's also a separation of duty example we saw there. Now let's see a lockdown user. This is the last example I'm going to show you. I'm going to log in as Mark. And notice Mark is severely constrained, right? Mark is told by the company, man, you can only access the Redis namespace. Yeah, although there are many, many namespaces on that cluster or in that project, you don't have access to any of that. You can only access this Redis namespace. And by the way, we're going to limit your access to a read-only privilege, which means you can't go mess around with things, right? So let's see how Mark would do that. Right? So again, got to fix this magnification thing. Log in as Mark. Same experience. So again, the consistency of giving all employees the same experience is really, really important, right? Otherwise, you struggle with training people, etc. Okay, so Mark's logged in, and Mark belongs to this group called, he can only see the Redis namespace, and he's a read-only user. So he's kind of stuck, extremely locked down. If you remember, there were a bunch of namespaces that were there for John Smith, but Mark can only see the Redis namespace, and that's what he's locked onto. And there seems to be one application here called Redis, and let's look at that a little bit, right? So in this particular case, I'm looking at Mark. Mark is logged in, and he's one of the developers. He's given limited privileges so he can help support the team. Now, if Mark says, "Hey, I'm going to go in and kubectl," and Mark's a smart guy, right? He says, "Hey, you know what? I'm going to see if I can see anything more than what I'm supposed to. I'm going to see what are all the namespaces that exist on this cluster," right? Well, what should happen? Well, Mark's a read-only user. He's locked to that particular namespace. He should not be seeing anything. Well, let's see what happens. What kind of enforcement gets done in this dynamic RBAC injection? So Mark's trying to see, I'm going to see all the namespaces. Well, if things work, it should error out and say you don't have any privileges here, right? So let's see if that happens, right? So you're seeing this delay again because the first time, the service account gets created, right? So dynamically. So when I run this again, get namespace, the second time run will be much, much faster. But notice here, when he tried to see and list all the namespaces, it said you're forbidden. Why? Because that's a cluster level privilege. Mark does not need cluster level privileges. Mark only needs to see what's in their Redis namespace. So if he comes and says get PO, he'll see all the pods in his Redis namespace, but he cannot jump out. So it's locked in. We can go one step further. Now I'm going to show you some fine-grained controls, right? Most companies go and say, hey, for my application developer in production, when we have a 7.1 issue, I want the developer to be able to view the logs of the containers. But man, I don't want them being able to exec into a pod because then they can see secrets. We'll talk about Kubernetes secrets in another session, but if someone has access to the pod, they can see Kubernetes secrets. So many companies say, oh my God, I can't allow that. I need my developers to not be able to do exec, but I want them to only see logs. So let's see that, right? So in this particular example, I'm going to try and view logs, and I'm establishing the zero trust channel back to my cluster. And in 1 second, Mark is able to see the logs of that particular pod. Everything works. But now Mark's a smart guy. He says, you know what? I'm going to try and see if I can exec him. Now, because he's a read-only user, he should be blocked. So let's try that. And you notice here, when he tried to exec, it says, hey, you don't have enough privileges because you're a read-only user. So I'm going to block you, right? So this is, this level of enforcement. Imagine if you had to do it by hand, cluster by cluster, user by user. At that time, you're asking yourself for, a crazy amount of pain and non-compliance is just not worth it, right? So my recommendation is, build out, what you need to do in summary here. Let me go back to my slides here. Model out an architecture with multi-tenancy and various levels of roles and permissions, and model out an example like this, right? Whatever works. If you're doing Kubernetes for the first time in a company, I would say get this right the first time, because undoing it is a royal pain, right? And you'll never know if you cleaned up properly or not. So I would suggest make sure, build this up in a manner where you delegate permissions to the right people. You structure your access with a certain documented model. And, very likely there are going to be people who will come and go. Like John Smith might be the project admin today. Maybe there'll be a second person who comes on. Maybe John will leave the company. Maybe Mark will start life as an app developer, get promoted as a project admin. This is going to constantly change, right? People are going to move around. business units are going to get created and collapsed. So it's a very dynamic, changing environment. So make sure that you tie all of this back to a source of truth in your company, like an Okta or Azure AD or AD or something like that. Tie it back and provide people a great single sign-on experience where they have seamless access to what they need, powered by their role in the company, right? That is defined in the source of truth, which is your company directory. So that's what I would recommend as the best practice. And then just to kind of recap, please don't do these, right? Just because it's painful for people to access, please do not expose your API server on the internet. You don't want to get hacked. You don't want to get DDoSed. We even tried this once just for kicks. We kind of set this up this way, and man, we got probed within 3 minutes of a cluster coming up. So there are people whose day job seems to be probing and finding vulnerabilities to other people. So they're going to find you very quickly. So don't take the chance. It's not worth it. Even if it's a dev or a QA environment, please don't do it. That's number one. Number two is don't give God mode access to all users. Yeah, it's sometimes clunky to do this, but there are easier ways that I've showed you. Employ a per cluster, per user based model with dynamically stitching together RBAC based on user's identity. Give your people a single sign-on experience where you don't have to train them. It'll be seamless for them. And number three is employ MFA where possible. In the demo, I showed you this multiple varieties of options possible. Most of these products features are supported by IDPs. So in the example I showed Chris logging in with and requiring the strongest form of authentication, like a YubiKey hardware token. And the other user, I showed an example of using a MFA app-based authentication with push notifications. There are other options also possible based on your company requirements. And number four, we'll talk about audit. This is the last thing I'm going to show you. Now, we just saw some examples, right? We saw Chris doing something, John doing something, Mark Lee doing something. We just saw a bunch of users access stuff. So I'm going to leave you with this last part, which is we're going to try and reconstruct who did what and when, right? A bunch of people accessed it. Let's see what that looks like. Okay. And just so that you might not remember all the names, so these are the people that we're going to check, right? So let me log in again into my my org. I'm the top level admin, and well, thankfully here there's an audit trail that is maintained out of the box. So I want to go and see, hey, who on earth accessed the QA project in the last hour, right? Well, John Smith accessed it. And if I increase the time a little more, the other people who accessed it. And if you look at Mark Lee accessed this project, there are other people who accessed it, right? Mark Lee did a bunch of things. All this is cool. Now I want to go and see, hey, what did they do really? Did they come in through a browser or CLI or kubectl? So they came in through a browser, so I know how they came in. I know they came in through single sign-on. I want to see who the hell is this Mark Lee? So we'll go find the user as well, right? Now I want to go in and see, hey, did they do any funky kubectl commands? Can I at least reconstruct what they did and when? So you can see that too. So you can go in and say, hey, I want to see all the commands that Mark Lee performed, right? And I want to filter that down to the QA cluster, right? And I get a view into all the API details that the user did with via kubectl. So quick example showing how easy or hard it is for people to close the loop and figure out who did what and when. And that's kind of the audit trail part. So these are the really important aspects of running a true mission critical Kubernetes operations platform. It's not worth the pain of doing it yourself because it's going to be one thing after the other. And just want to show you here. Here's an example of all the users that we configured. And so if I want to go in and see, hey, when did Mark Lee log in? Mark Lee logged in on the 20th at 9:35, which is a few minutes ago. He logged in. I can go and revoke the person's kubeconfig. I can go change the kubectl settings. I can manage their keys. And so all these options, you'll need to think about how can I control things at a fine-grained level for users from an access control perspective. So going back, access control for Kubernetes, difficult problem. There are solutions in the market. Definitely, if you're starting out with a Kubernetes initiative or you're halfway through it, think about this. You can be a hero by enabling your developers with a fantastic access experience. And you can be a hero within the company by providing a highly compliant and a secure operating environment. So think about that. And I would say tackle that first because it's the hardest problem to nail. And once you train people to do something certain ways, it's kind of impossible or hard to change it quickly. So make sure you train them with a model that is scalable. Let me pause there and see if there are any questions, if there's anything particular that you did not see or you want to see and explore further. Happy to take it on. I guess there's no questions. Joe, that's all I had, Joe. So I just have one slide for a wrap up. Is there anything else you want to?
No, nothing else from me. I think it was really relevant, actually. It goes back to the conversation you and I was having last week, where the speed at which Kubernetes is being adopted by organizations and people, you kind of overlook facts like who's got access to what, is the security set up in place, how do you track what a user's done? So no, really relevant. And if there are any questions from anybody, just feel free to take yourselves off mute or write it in the chat box for Mohan.
Absolutely. So we're happy to help. Just as an FYI, some of these challenges that I talked about, these are some of the organizations that we worked with to solve these problems, right? So, telecom, large ISV, healthcare company, financial company, one of the largest hosting providers. Well, you guys know this, MoneyGram financial company, Hewlett Packard, very large ISV group within Hewlett Packard. Every one of these organizations uses access control, and of course they have no choice. They have hundreds or thousands of developers in some cases. Everyone needs to do stuff in a easy, quick manner without struggling through access control issues. So this is a problem that everyone has. And that's kind of why we thought we'll pick it up first and talk through it. If you want to just type it on chat, is there any suggestions on topics for the future? Like if you had to pick between QoS, auto scaling, Kubernetes secrets, upgrades, or something else that maybe is not there in this slide. If you have any particular preferences, email me and Joe, or let us know here, and we'll prioritize that over the others.
Yeah, absolutely. For those that missed at the start, this is going to be part of a series. So Mohan will be coming back in a couple of weeks' time to do kind of episode number 2, I guess you can call it. And yeah, it'd be good to get your guys' feedback from the audience and figure out, what we should talk about, how we should tailor these events and make them more inclusive. So any feedback, get in touch with myself or Mohan.
Yeah. The other question for you guys is, I tried to avoid showing raw, low-level YAML. It's not the most fun thing to view that. Try to avoid CLI because it doesn't render well on Zoom. But if you guys prefer that, because that's how you operate, we can transition back to that mode. Let us know what level you want us to see at. And Joe, this is going to be recorded and posted on the YouTube channel, right?
Correct. Yeah. So in the next 3 to 4 days, it will be up on the YouTube channel. If you guys don't know it, it's DevOps For Everyone on YouTube. Go on there and you'll be able to find this and all the other recordings from previous meetups as well.
Fantastic, Joe. I think that's all we had.
There's a question in the chat here, Mohan.
Yeah, I'm reading through that. Yeah, it's from Ranjit. Ranjit, I think this may require a conversation. I'm going to type my email here. If you could just maybe reach out with an email, and I think we may need to have a conversation to see if there's anything we can do or not. It's going to be different for every people, right? Like the conversation will be more like, what are the problems you're trying to solve? And maybe you're all good with what you have, or maybe not. And then is there something we can do to help? And we're happy to explore that together. So remember, the company, we're not a .com, it's a .co. So you can either go to Mohan at Rafay.co, or you can go to info at Rafay.co. And of course, if you go to info, it'll be somebody who'll pick it up. If you come to me directly, you can have a deeper technical discussion, and we can continue with the same context we had. Yeah. So Ranjit, looking forward to you reaching out.
Brilliant. Well, if he's put, okay, cool, thanks. So yeah, great, good feedback there already. So if that's it, then I just wanted to say thanks, Mohan, and appreciate you jumping on first thing in the morning for you over there. And I look forward to episode 2 in next coming weeks. And I'll put a message out, everybody, on my LinkedIn of when the next meetup's going to be. So look out for that.
Thank you all for sticking it out. I really appreciate it. I hope it was useful and interesting. And thank you, Joe, again, as usual, for hosting us. Enjoyed it.
Not a problem. Hopefully we'll be able to come over to the West Coast US and do it in person soon.
Yeah, that'd be lovely. Yeah.
Brilliant. All right, guys. Well, all the best. Enjoy the rest of your day.
Yeah.
Cheers, man. Bye.